I am Anil Kumar. Welcome to my series on trigonometric identities. We have learned how to derive the fundamental trigonometric identities, and we have also seen how to use these identities to simplify expressions, solve equations, and prove identities. In practice test 2, we'll take few questions based on the concepts learned. The question number 1 here is to simplify sine to the power of 4x minus cos to the power of 4x over cos square x plus sin x cos x. The formula sheet is right here for you, where we have summarized most of the formulas which will be required to answer the questions in this particular test. So you learned the quotient rule, where tan x or cotangent x could be written in terms of sine and cosine. The reciprocal connects the secondary ratios with the primary ratios. Pythagorean identity, sine square theta plus cos square theta equals to 1. Even odd function, sine is an odd function, cosine is an even function. And then if you are given a point, then any point on a coordinate plane, PAB, could be written in terms of sine and cosine, where A is distance of the point from the origin times cosine of the theta, B is distance from the origin times the sine of the angle theta. In general, sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tan is opposite over adjacent. The co-function identity is that sine of 90 minus theta is same as cos theta. Reason being that this is the angle theta, the other angle is 90 minus theta. The sides opposite and adjacent flips when you look from the other side. And so that makes sense. As far as the coordinate plane is concerned, all are positive in quadrant 1, sine is positive in quadrant 2, tan in quadrant 3, and in quadrant 4, only cosine, or its reciprocal secant, is positive. Now, with that in mind, let's take up the very first question, simplify the expression. So the numerator, let's rewrite the question first. It is sine to the power of 4x minus cos to the power of 4x over cos square x plus sin x cos x. To prove trigonometric identities or to work with them, remember we also need good knowledge of algebraic identities. Now in this particular case, difference of squares is very important to understand. So as you know, a square minus b square can be written as a plus b times a minus b. So this is the first identity which we are going to use to simplify. The numerator therefore can be written as sine square x plus cos square x times sine square x minus cos square x. Perfect. We can factor the denominator. Cosine term is common. So we have cos x as a common factor. We're left with cos x plus sin x as the other factor. Now, in the numerator, we have the term sine square x plus cos square x. What is that equal to? Well, that is just 1. And 1 times anything should be the number itself. So we are left with, in the numerator, as sine square x minus cos square x. The denominator being cos x times cos x plus sin x. Now again we can apply the difference of squares, the formula which we began with, correct, and simplify. So we could write this as sin x minus or plus cos x is the product of sum and difference. What do you notice? One factor is common in numerator and denominator, and that can be cancelled. So that will help us to simplify the given expression. Correct? So what we get here is sin x minus cos x divided by cos x. You could write them separately as sin x over cos x minus cos x over cos x. That gives you sin over cos is tan minus 1. So that becomes your answer. Simplified form in this particular case will be tan x minus 1. Perfect. Let's move on and take up the next examination style question. The question here is, find exact value of sine theta and tan theta if cos theta is minus 3 by 4 for a reflex angle theta. Now what does it mean? We are saying reflex angle theta. Reflex angle theta means that the angle theta is greater than 180 degrees, correct? So that means that we are talking about the third quadrant, correct? So we are talking about the third quadrant. So if you are in third quadrant, this is quadrant 1 for you, this is quadrant 2, quadrant 3, and quadrant 4. Then you can apply the cast rule. C is in quadrant 4, right? You can apply the cast rule. And you know that only tan is positive, sine and cosine are negative. So you are in third quadrant. So we have a negative value for sine, positive value for tan. The other part here is given to us as cos theta is given to us as equal to minus 3 by 4. It makes sense. Cos is negative, right? So we are in quadrant 2. So we know sine is negative. And tan is also negative. Positive, sorry. Tan will be positive. Right? Since we are in third quadrant. We're talking about quadrant 3. So let me write down here quadrant 3. It's not question 3. It is quadrant 3. Okay. So now let's work on the values. We're given cos theta as equal to minus 3 by 4. So we'll work for any triangle which is in quadrant 1. So that is our basic, right? So let's say this is alpha. Acute angle we'll work with. So we'll consider a triangle here in quadrant 1 where all values will be positive. So we always work with acute angle. So cosine is the ratio of base to hypotenuse, correct? So remember SOHCAHTOA, which is sine is opposite over hypotenuse, cos is adjacent over hypotenuse, and tan is opposite over adjacent. So cosine, which is given to us, is adjacent over hypotenuse. So that is your adjacent side. This is the hypotenuse. So you get minus 3 over 4. So what is going to be the other side, the opposite side? It is going to be 4 square. So we can find out this side, which is going to be 4 square minus 3 square square root, which is 16 minus 9, right? So if you take away 10, it is 6, now it is 7. So the trick part in the question is that if you by mistake write 4 in the opposite side, you get all the wrong answers, right? It's not the 3, 4, 5 right triangle. The other side is square root 7. So we found that the opposite side here basically is square root of 7. This is for the triangle in quadrant 1. And now you can write down all the values. So we can now write our answer and we can say, well, sine theta will be, it is in quadrant 3, which is going to be opposite over hypotenuse. So it will be square root 7 over 4, but with a negative sign. And tan theta is going to be positive. It will be square root 7 over 3. Correct? So that becomes the solution. So you can find the third side. So you can say find third side or find opposite side with Pythagorean theorem. So, while working with trigonometric identities, we have to take care of a lot of algebraic identities which we have learned. Pythagorean theorem is very important. Now let's look into another question, which is question number 3 for us. This is also the last question of this test. A combination of many questions are given here to review the concepts. The question is, the line y equals to minus 5 over 12x makes an obtuse angle theta with the positive x-axis. Find the value of tan theta. Find exact value of sine 2 theta if sine 2 theta equals to 2 sine theta cos theta. Consider the function f of x equals to square root of 1 minus sine square x over sine x. Simplify the expression and then evaluate f of theta. Is f theta equals to cot theta? Justify your answer. Correct. So let's begin with the very first part, understanding what is given to us. We're talking about a line. So let me sketch the line here. Y equals to minus 5 over 12. So it's dropping, correct? So line is coming downwards with a slope of rise over run 5 over 12. So let's say that is the line. Okay. Now it goes through the origin. It makes an obtuse angle theta. So this is the obtuse angle theta which we are talking about. Now how does that relate to tan theta? Since we need to answer the question that what find the value of tan theta. So if you recall, slope m, which is in this case minus 5 over 12, is basically equal to tan theta. So slope of a line is directly equal to tan of theta. It makes sense. Since you can see here that if I take a point, and we know that from here rise over run is 5 over 12, it really means that this point should be minus 5 and that should be 12, right? Now since it is going down, we have a negative slope, correct? So that gives you a sense that this particular triangle, which is similar, right, will also have the same situation. So the principal angle is theta. Let's call this as alpha, right? So principal angle is theta. Does it make sense to you? So many times, sometimes students are confused about how they are related. The related acute angle is alpha, of course, which gives you the slope minus 5 over 12. But the question specifies that the obtuse angle is theta. And in this case, you can clearly see that with the positive x-axis, the obtuse angle is actually the principal angle theta, right? So that becomes the case. So clearly from here, find the exact value, find the value of tan theta. So we know that tan theta is equal to minus 5 over 12. And we also know that theta is in quadrant 2. It's an obtuse angle, correct? Since we're given that theta is obtuse. As you can see from here, correct? So to begin with, we know what tan theta is. Now on the next page, let us find the exact value of sine 2 theta, which is equal to 2 sine theta cos theta. It's a standard formula. So we know that tan theta is equal to minus 5 over 12. We also know we are in quadrant 2. And so sine will be positive and cos will be negative. So let's make our acute angle triangle. Alpha. Tan is a ratio of opposite over adjacent. So we can find the third side, which is 12 square plus 5 square square root, which is 144 plus 25 square root, and which most of you know is 13. This is a standard triangle. Correct. Now, as we are in quadrant 2, let's get back to our quadrants. We know the cost rule. We are actually working in quadrant 2. So sine has to be positive, correct? So we'll write sine theta as equal to positive value of 5 over 12. Right? So how do we get that? We know sine is a ratio of opposite to hypotenuse, cos is adjacent to hypotenuse, tan is opposite to adjacent. So we get opposite to hypotenuse as sine. As far as tan cosine is concerned, cos theta is adjacent to hypotenuse. So it is 12 over 13, but it is of negative sign since we are in quadrant 2. Right? We need to find the value of sine 2 theta, which is equal to 2 times sine theta cosine theta. So sine 2 theta is 2 times sine theta cosine theta. So it could be written as 2 times 5 over 12 times, 5 over 13, opposite side was 13, times minus 12 over 13. Correct? So you can write down 13 times 13 is 169, and we get negative out above. So 10 times 12 is 120. So sine 2 theta is equal to negative 120 over 169. Is that clear to you? So that is how we are going to solve the given question. Perfect. So important thing again is to put your knowledge together and then get the answer. All the concepts are required. We use the Pythagorean theorem to find the third side of the triangle. We solve the triangle in quadrant 1. We understand that actually angle theta is an obtuse angle which lies in quadrant 2. So sine will be positive, cosine will be negative. Multiplying the 2 and times 2 gives you sine 2 theta. The value can be calculated as shown. Now let's look into the third part. Okay. Now we are given a function f of x equals to square root of 1 minus sine square x over sine x. Simplify the expression, then evaluate f of theta. So first let's simplify the expression itself. We are given f of x as equal to square root of 1 minus sine square x over sine x. Now what is 1 minus sine square x? It is cos square x, correct? Over sine x. What is square root of cos square x? Most of you may write just cos x. That will be wrong. Since square root is always positive, therefore we'll have to take this as an absolute function. You get the idea? So f of x is actually equal to absolute value of cos x over sine x. Perfect. The next part is then evaluate. It says then evaluate f of theta. So now let's try to evaluate f of theta. So what is f of theta equals to? So theta is the angle, the obtuse angle which we are talking about, where tan theta is this, right? So coming back to a triangle, let me make the triangle here. We're talking about a triangle with the tan value 5/12. Let's get back to B and see what we did. Yes, 5/12. That is correct. So 5/12, and there you get 13. So it is not to the scale the way I've drawn. Anyway, let me just redo. It makes more sense. We are saying this angle is alpha, right? A constant reminder that we are working with a positive triangle in quadrant 1. However, theta lies in quadrant 3, 2, right? So we are actually working in quadrant 2. So f of theta is when cos theta is given to us as, let's write down the values. We don't really need to find the angle, but we'll take the positive value of cos x. So it will be the positive value of cos of theta over sine of theta. Sine is itself positive in this particular quadrant. Now the cos value is 12/13, right? So the absolute value, actually it is negative, but when you take the absolute value, it becomes positive. And the sine is 5/13. So what you get here is 12/13 over 5/13, and clearly it is 12/5. So that is what you get, 12/5. It's a positive value, not negative. Now part D of the question is, if f of theta is f of theta equals to cot theta, justify your answer. Well, as you can see here, it is not really cot theta. If it was cos theta over sine theta, then it was cot theta, correct? So let's try to justify on a fresh page. We actually found that f of theta is equal to absolute value of cos theta over sine theta. And we did get the value of f of theta as 12/5. And remember, we are in quadrant 2. The cast rule. Only sine is positive here, or it's reciprocal. But cot theta is negative. So we can say in quadrant 2, cot theta is negative. Since f of theta is positive, it is not equal to cot theta. Do you get the idea? Now that makes a huge difference. This absolute value makes the huge difference. Do you see that? So I wanted to highlight the point that if we have square root of x squared as it is given here, it is not just x, but it is absolute value of x. Is that clear to you? So it's kind of important to understand this part, and that makes a lot of difference in examination test paper. So in this, if you do not follow this particular concept, and let me summarize here, the concept here learned is that square root of x squared is absolute value of x, not just x. Perfect. So with that in mind, let's close this test paper. We'll take up another with practice questions on challenging questions based on trigonometric identities. I hope it makes sense to you. Feel free to write your comments, share your views, and if you like and subscribe to my videos, that'd be great. Thanks for your time and all the best.